Alright, this is Algebra 2, Solving Equation, Part 2. I'm going to do numbers 10 through 17. So number 10, the solution set for this equation. Now this is a multiple choice. We have talked about that if it's a multiple choice on the Regents, they give you an equation and possible answers. All you really need to do is plug them in and to see which answers work. Which we're going to have to do anyway. But I am going to show you the math, because if this shows up as a show all your work question, you're still going to need it. Alright, so first thing we need to do is to isolate that radical, which it is. It's already by itself. So now that it's by itself, we are ready to square both sides. Squares and square root cancel. So that gives me b squared is equal to 2b squared minus 64. I'm going to subtract b squared so I can set the equation equal to 0 since it's a quadratic. That gives me b squared minus 64. That's difference of squares, so I can factor b plus 8, b minus 8. Set each factor equal to 0. And like I said, now we're at the point where we got to check the answers, so we could have really started the multiple choice problem there. So I'll check the positive 8 first. So that would say 8 is equal to 2 times 8 squared minus 64. 8 squared is 64 times 2 is 128. And 128 minus 64 is 64. Square root of 64 is 8. That checks. Check the negative 8. Negative 8 is equal to square root of 2 times negative 8 squared minus 64. So we get negative 8 equals, put that in your calculator, and you end up with 64. Square root of 64 is 8. The radical is already there. 8 does not equal negative 8. So it doesn't work. Only positive 8 is our answer. Number 11. The half-life of a radioactive substance is 15 years. Write an equation that can be used to determine the amount S of t of 200 grams of this substance that remains after t years. Determine algebraically, blah, blah. Okay, so first we have to write the equation. So this is an example of half-life, which is exponential decay. So they said S of t instead of the y. The beginning amount, 200, and half of it remains after each cycle to the time. Now time is represented in years. This thing does not cut itself in half every single year, so we have to adjust that t. So I have to take whatever t is and divide it by 15. So think about it. If the time were 15 years, we'd want the half-life to execute once. 15 over 15 is 1. If the time were 30 years, the half-life would have had to execute twice, and 30 divided by 15 is 2. So when the half-life is anything other than a year, you take the number of years and divide by that number to adjust how often it happens. So there's our equation. Determine algebraically to the nearest year how long it will take for 1/10 of the substance to remain. Well, we have 200 grams of it right now. 1/10 of 200 is 20. So we want to know when 20 milligrams remains, which is our ending amount. So I'm going to fill the 20 in for S of t. And you have a variable in the air. We have not yet reviewed logs, but you have done them this year. So anytime you have a variable in the air, you need to use logs to get it out of the air to solve for it. In order to take logs, you have to isolate the term with the variable exponent. So we need this by itself. That suggests that I should divide by 200. When I divide by 200, I get 1/10. So I could have started right from there, but I wanted to show you where that number comes from. Alright, now that we have isolated the term with the variable in the air, now we're going to take the log of both sides. So we're going to do log, I'm going to write that as a 0.1 instead of a fraction, equals log 1/2 to the t over 15. And back when you were in the log unit, you learned that in order to expand this log, any exponents that were up in the air came down and multiplied to the log, because this means exponent. So you have an exponent raised to an exponent, and that by exponent rule say you're supposed to multiply them. That's why it comes out of the air. So we have t over 15 log, I'm going to write the half as 0.5. Alright, so now my variable is out of the air. I need to get it by itself. So the first thing I'm going to do is divide by log 0.5. So in my calculator, I'm going to type log 0.1 divided by log 0.5. Log 0.1, make sure you remember to end the parenthesis, divided by log 0.5. And that's going to give us 3.3219288095 equals t over 15. And now if I multiply both sides by 15, I will have my answer. I've got 49.8. They said nearest year, so that would be 50 years. And that was probably a 4-pointer on the Regents exam. Alright, number 12. The value or values of x that satisfy this equation. Again, it's a multiple choice. They give you an equation, possible answers, you can just plug them in and check them. I'm going to show you how to do it if it weren't a multiple choice. Isolate the square root, which we have. So you square both sides. That requires that you wrap up the entire side and square it. Square and square root will cancel. And I have to write this out twice and double distribute. So x squared minus 4x minus 5. You get 4x squared minus 20x minus 20x plus 100. I'm going to move everything over and set it equal to 0. So subtract the x squared, add the 4x, add the 5. Subtract x squared, add the 4x, add the 5. So 0 equals 3x squared. If I combine all of these together, I get negative 36x plus 105. Those numbers are a bit big. I do know because it's a multiple choice question, it should be factorable. So I'm going to divide everything by 3 to make those numbers smaller and more manageable. It also means I no longer have to use factor by grouping. So two numbers that multiply to 35 but add to negative 12 would be x minus 5 and x minus 7. Set them each equal to 0 and we get 5 and 7. Alright, now we have to check to see which ones work. Don't have a lot of room for my check, so I'm going to blow this up a bit. Alright, let's fill in a 5. 5 squared minus 4 times 5 minus 5 should be equal to 2 times 5 minus 10. Alright, well, I'll do it all at once here. Square root of 5 squared minus 4 times 5 minus 5 gives me a 0. And 2 times 5 is 10, minus 10 is 0, so 5 definitely works. Let's go check the 7. 7 squared minus 4 times 7 minus 5. We want that to come out to be 2 times 7 minus 10. Alright, so let's check that. Square root of 7 squared minus 4 times 7 minus 5 comes out to be 4. And 14 minus 10 is also 4, so they both work. The answer is number 3. 13. Given that function, the solution of c of m equals 0. So they want the c of m to be a 0. So where I see c of m, I'm going to substitute a 0. Now again, they give us an equation and possible answer choices. You really have to plug them in and check. But I'm showing you in case you have to show the work for a different question. All right, we're going to factor this. I can take an m squared out of my first group. I can take 4 out of my second group. So I get 0 equals m squared plus 4 in one parenthesis and m minus 2 in the other parenthesis. Set them each equal to 0 because I cannot factor in m squared plus 4. That's not difference of squares. So m equals 2 over here. This one I'll solve, subtract the 4 from both sides, then square root both sides, and square root, I get a positive and negative answer every time I take a square root that wasn't there. And the square root of 4 is 2, and because it's negative, 2i. So I get 3 answers, 2 and positive negative 2i. Now remember, the highest exponent in an equation tells you how many answers you're supposed to get. I'm supposed to get 3 answers. I don't need to check any of these answers because I don't have fractions and I don't have radicals. You can check if you like, but it's not required. 14. All right, we have fractional equations, which we saw on last week's sheet as well. First thing, I hate subtraction, so should you. Distribute the minus sign. We need a common denominator. Well, I definitely need an x plus 3 in parentheses. And then between a 2 and a 6, I'm going to pick the bigger one, 6, because 6 will go into 6, 2 will go into 6. So we need to make all these fractions have this for a common denominator. Multiply the first fraction by 6. Second fraction, that 2 needs to be multiplied to a 3 to turn into a 6, and I also need the parentheses. Third fraction just needs the x plus 3. The last fraction, again, needs the 3 and the x plus 3. All right, let's multiply. That gives us negative 18. 1 times 3 is 3, so I'm distributing the 3. Oops, that's a plus. 3x plus 9. And distribute the x. There's x squared plus 3x. And distribute the negative, well, the negative 1 times 3 is negative 3, so we're distributing a negative 3. Negative 3x minus 9. Ditch the denominators. And I'm going to combine like terms. So 3x minus 9 on the left, x squared minus 9 on the right. It's quadratic, set it equal to 0. So I have 0 equals x squared minus 3x, and the 9's cancel. That's okay. Factor. GCF is x. Can't factor anymore, so set each factor equal to 0 and solve. So we get 2 answers, 0 and 3. And remember, if you have fractions or radicals, you got to check to make sure they're not an issue. So if I put a 0 in for the x, that denominator will not be 0. If I put the 3 in for that x, the denominator would not be equal to 0. So our 2 answers are 0 and 3. 15. Determine to the nearest tenth of a year how long it would take an investment to double at 3 3/4% interest rate compounded continuously. Compounded continuously was PERT, e to the RT. All right, so we need to find the time. The rate, let's see, that's 3 3.75%. So if I move the decimal twice, 0.0375 t. Now, what to put for p? They didn't tell us how much we were going to put in. They just said we want the investment to double. Well, if you remember that other log problem that I just did, if I pretend that I'm putting $100 in there and I want it to double, that means I want it to come out to be $200. And when we are solving this, we have to isolate the term with the variable exponent so we can take the logs. So if I were to divide by 100, I get a 2. And when I double my investment, I want a 2. 2 is doubling. Just like last time, they wanted to know how long it would take for 1/10 to remain. And when we did the division, we got the 1/10. So I don't need to worry about the initial amount. I just know that I want the principal to be doubled times 2 when I'm done. I'm going to put a 2 there. And again, to get the variable out of here, you need to log both sides. Because the base is e, it's going to be a natural log. So log 2, and remember we put the exponents down in front when we log both sides. So I don't have to show that as a separate step. Now, the first thing I would get rid of is the log of e, but this is one that they really want you to remember. Log of e has a value, and it's one that you should know. When you have an ln, the base is automatically an e. This little base down here is an e. So remember, log asks the question, what exponent do I put on this base of e to get an answer for e? Well, the exponent would be 1. So ln e always has a value of 1. Always. So this is just a 1. And if I divide by 1, nothing changes. So I'm just going to kind of cross them off here. But I'm going to put a 1 on my paper so that whoever's grading it understands that I realize that the value of that is 1. So now I just have to get rid of the 0.0375. So I'm going to take the log of 2 and divide it by 0.0375. So ln to end parenthesis, don't forget that part, 0.0375. And I'm coming out with 18.483 blah 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 equals t. And then it said nearest tenth of a year, so 18.5 is going to be our final answer. Alright, 2 more for this video. Number 16. When factoring to reveal the roots of this equation, which equations can be used? Well, they have different factorizations there, so that means I would end up having to factor different ways every time. So instead of factoring, since this is multiple choice, I'm just going to multiply out what they give me and see which one matches the question. So if I distribute these guys, I get x cubed plus 2x squared minus 9x minus 18 equals 0. And that's exactly what the question says, so I know the first one works. All right, let's do this one. Distribute those, x cubed minus 9x plus 2x squared minus 18. And if we realize that those two terms are just out of order, it's the same thing. So number 2 works. All right, number 3, we have to do a double distribute. So x cubed minus 9x minus 2x squared plus 18. Nope, we have a sign issue. Number 3 does not work, so choice number 1. Alright, 17. Solutions to this quadratic equation. Well, I'm seeing stuff with radicals in there, which makes me think that quadratic formula might be the easiest way. So I'm going to set it equal to 0. 5x squared minus 2x plus 4 equals 0. And so there's my a, my b, and my c. X equals negative b. So since it's already negative, that's going to be 2 plus or minus b squared. 4 minus 4 times a times c all over 2 times a. And we're just going to clean up the radical there. So 4 minus 80 is negative 76. I think. Alright, so yeah, 4 minus 4 times 5 times 4. Yeah, negative 76. Alright, so we know we got to bring the I out. So we're going to simplify square root of 76. So 2 and 38, 2 and 19, group of 2. So that 2 is going to come out. So we end up with 2 plus or minus 2I root 19 over 10. The only one that has a 19 is number 2. If you want me to go one last step to show you the simplify, you put the 2 over the 10, 2I root 19 over the 10, 2/10 makes 1/5, so that also makes 1/5, and it's customary to put the I on the end. So that's how it ends up looking like number 2. Alright, part 3 of the video will be posted later.